Hey, and welcome to this lesson on objects that are being thrown. The student objectives for this lesson are to apply what we know about vertical motion to model thrown objects or launched objects or objects that are flying through the air. Essential questions: what is special about thrown objects and how we can model them? So what's special or unique about those certain types of problems? Below you will see the Common Core standards. So now, a couple unique properties and things that will happen when we're talking about objects that are thrown and the way we can set up the vertical motion equation. Now, instead of an object just being dropped or falling, it's going to be launched or it's going to be thrown. So it's going to be given some initial velocity. So instead of it just being 0, it's going to be a number. There's going to be an initial velocity there, whether it's being thrown up or thrown down. An object will either have a positive or a negative initial velocity. So if you think about the y-axis, the vertical axis here, when we move up, we're moving in the positive direction. Therefore, if an object is thrown up, the initial velocity is positive. It's moving in the positive direction. If we move down, we're going towards the negative numbers. So we're going in the negative direction. So if the object is thrown down, the initial velocity is negative. So let's attempt this real world problem. So essentially we've got Leslie. She's on top of a cliff. And I'll draw that cliff out for you. So here's a cliff. And there's the ground below it. And then here is Leslie. She's on top and she's just having a ball throwing rocks off the cliff. Okay? She's going to throw a rock. It's going to go up. And then it's going to come back down. How do I know she's throwing it up? Well, it tells me upwards. Also, it's plus 15 feet per second. Okay? So, she throws that rock. The initial height of the rock, when she throws it, is 50 feet. And the ground we'll call 0 feet. So when you do vertical motion problems, there's two things you could be asked for. You could be asked for height, you could be asked to find the height and be given the time. Or you could be asked to find the time and be given the height. Whenever you have any type of two-variable equation, usually you'll be given one value and asked to find the other one. Well, it's no different for vertical motion. So there's two problems you can have. You can have how long, whenever you see how long or something that has to do with the time and then you're given a height. How long, for example, does it take to reach 0 feet or 15 feet? That's when you're substituting that height in for h, like we've done before in the falling objects. How long will it take to hit the ground? Well, the height at the ground is 0, so I'm going to substitute 0 in for h and find t. The other way is like this problem. So we'll do this. If we want to know the height of the rock after 2 seconds, so I'm given t equals 2 seconds, and I'm given h. So after 2 seconds, I'm asked to find h. So after 2 seconds, how high will my rock be? Well, if we look at the problem, you start with the vertical motion equation. I'm going to substitute all my variables in from the problem. 15 feet per second, and 15 feet is my initial height. And then I'm going to substitute 2 in wherever I see a t. And from there, I'm simply going to solve out this arithmetic. Negative 16 times 2 squared plus 15 times 2 plus 50. If I solve all that out, I get 16 feet. So, how high is the rock after 2 seconds? It's 16 feet off the ground, which would look something about, probably right about there. So after 2 seconds, it's right about there. Now we're going to look at the other scenario. Now the question says if we want to know how long, so there it is, how long, so I'm looking for time, it takes for the rock to hit the ground. We substitute 0 in for h. At the ground, the height is h. Ground height is 0, sorry, not h. At the ground, height is 0, therefore I'm substituting it for h, the height that was given to me, 0. And solving for t using the quadratic formula. Now you could use many other concepts to factor this equation, or you can use GCF or completing the square. Quadratic formula will always work. Okay, so you can always use the quadratic formula. That's why I'm showing you how to do it. Pretty much, I'm finding the zeros of this function. This function right here. I'm finding out what t values make the function equal 0. So I can use the quadratic formula. This time it'll only just be in terms of t instead of x, because t is my independent variable. So t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to substitute in my a, b, and c. And if I solve it out, I should get 15 plus or minus 5 times the square root of 137 divided by 32, plus or minus, right? Well, I'm only going to take the plus side, so I'm only going to take 15 plus the square root of 137 all over 32. Okay, and if I wanted to put that into a decimal, it would be I'm putting it in my calculator right now. It would be about 2.23 seconds. So it takes the rock 2.23 seconds to hit the ground. Something I just realized I messed up on. See, even I mess up. It's okay. I forgot to copy that 5 from right there, so make sure you include everything. So here's my answer in fraction form. It's okay to leave it there. It's also okay to use your calculator and use decimals. Either way is fine. That's all I have for you for this lesson. I hope you enjoyed yourself. Hope you really learned some stuff. If you're still a little confused on something, go back through the video, take some better notes, really work through it, and then go ahead and practice it. Give it a try on the homework, and let me know if you need any help. You can always contact me on BBIM or text message or phone, whatever's easier for you. And I hope to see you in the live classes where we can get into this in a little more depth.